So today we are going to begin reviewing things about some functions. So first thing that we have to review is from Algebra 1. So whether something is a function or a relation. So pretty much any correspondence is a relation. So it's whether or not that relation satisfies the additional requirements to be called a function. So you can see the definitions here. So relation, any correspondence where we take something from the domain and we assign it to something from the range. A function is a type of relation where each element of the domain is associated with exactly one element of the range. So typically we've used X for domain and Y for range. Again, we can use whatever variables we want in a function, but each X can only be assigned to one Y if we want it to be a function. So domain and range you should also be familiar with, inputs and outputs. It's also important that you know that the domain is your independent variable and the range is your dependent variable, because the inputs are what determine the output. So meaning that the output is dependent upon the value of the input. There are some rules for domain that we're going to write up here at the top that you have learned throughout your math career, but I feel it's important for us to review. First rule of domain that is helpful to remember is that all polynomials have a domain of negative infinity to infinity, meaning all real numbers. Domain can be anything if it is a polynomial. So other domain rules that are important to remember is that you can't have 0 in the denominator of a fraction. So that is going to restrict the domain on rational functions, because rational functions have fractions. And so when you have a rational function, you have to make sure you look at that denominator and exclude any values that would make the denominator equal to 0. Another domain rule that's important is that you can't have a negative under an even indexed radical. So square root, fourth root, sixth root. If the index is even, you can't have a negative underneath there. Obviously, square root is the most popular, but any type of rational function, that rule would apply. When we are talking about functions, inputs and outputs, the term image is something that they use to refer to the output value that's associated with a specific input. So they might say, find the image when x equals -5. So that means just find what the output is when x is that specific value. Function notation, you should be very familiar with. We use this from Algebra 1 on. So we typically read this guy right here. That is read f of x. That's traditional function notation. It does not have to be f. It does not have to be x. You can have g of x. You could have h of t. But remember that the value is the f value. the number x is the input value. So if, for instance, you were told to find f of 2, that means to plug in 2 for the variable, often x, but could be any variable we want. The last thing that is in this section will be new for most of you. Maybe if you've taken AP Pre-Calc or Calc AB, you'll have seen this difference quotient before. Other than that, I think it's probably new. So this is just a formula that we're going to be using for some of the problems. It's down in example 3, so we'll come back to that a little bit later. All right, so let's look at how we need to be able to use some of these definitions and what we need to be able to do with these functions. So example 1, determine whether each relation or equation defines y as a function of x. So this is fancy wording. And again, I'm copying that wording from the text, so you're going to see this wording. What that means in a more layman term is it's asking, is it a function? Why can they not just say, is it a function? I don't know, but they don't. So making sure that you understand what that is telling you is important. So it's just asking, is this relation a function? So meaning, does each input assign to exactly one output? So when we look at this first one, you could, if you wanted to, you could list out what your domain is, right? 0, 1, 2, 3. You could list out the range. So this is just review. This question didn't particularly ask us to do this, but I'm just reviewing. When you list domain and range, see how this 3 repeats as a range element? You only list it once. Oh my gosh, and I drew a parenthesis there instead of a brace. What am I doing? So those are our domain and range elements. What we are looking for is there any input, any domain element that is assigned to more than one output value? So sometimes you'll see these written as mappings also. So these are just other alternative ways to write this relation. So these input, output, 0 was assigned to -2. 1 was assigned to 3. 2 was assigned to 3, and 3 was assigned to 7. So if I look at my inputs, there is only one line coming out of each of them, which means that each of my inputs is assigned to exactly one output. It doesn't matter that the 3 is receiving 2 lines. That's okay. It's whether each input has exactly one output. So this one is a yes. Each input has exactly one output. Over here to determine if you are given an equation like this or a graph, it is quickest to determine if it is a function using what I will always abbreviate as VLT. Hopefully you know what that stands for. If not, that is the vertical line test. Remember that each input is only allowed to be assigned to one output. So that means if that definition is true, every vertical line can only touch one time. So depending on how much math you have had, this guy right here, because the y is squared and the x is not, is a sideways parabola. So it's not a quadratic function, but it is a parabola. Specifically, if I were to solve that for y squared, like this, that means that it's opening to the left. So if you know that because you've had conics in whatever previous high school math you've taken, then you can probably stop there and draw yourself a little graph and say, okay, I know, it kind of goes this way, and then say, okay, does that pass the vertical line test? Well, the very first vertical line I draw touches twice. So this one is a no, because it fails the vertical line test. Now, if you have not taken a course where you've studied conics and you had no idea that that was a leftward facing parabola, you could use your graphing calculator, but just remember you have to solve for y in order to do that. So I would then have to square root both sides. When I square root both sides, the very next step I have to remember a plus or minus. If you forget that plus or minus, then you're not going to get this on the screen because you have to graph two separate things in your y equals. y1 equals square root of negative x plus 1, and then y2 equals the opposite of the square root of negative x plus 1. So they would both have to be there in order to get both pieces of that graph. All right, looking at example 2, we're given two functions, f of x and g of x, and we are performing operations on those functions. So this right here is read g minus f of x. So I want to find g minus f of x and find its domain. This notation means the exact same thing as g of x minus f of x. So that's exactly what I'm doing to find this function. So g of x is this guy, square root of x minus 3 minus f of x. So subtracting that entire function. So that means that I have to distribute this negative, right? So it'll be plus x squared minus 2x plus 1. Now, when I write this function, remember that we should write them in order from highest exponent to lowest exponent. And square roots, remember, are a 1/2 exponent. So when I am writing my answer for the g minus f of x part, because it says find that function, I should start with x squared, then plain x, because that's x to the first, then the radical, because that's a 1/2 power. The constant should, of course, be last. So this is part of my answer. That is the function. Then it asks me to find its domain. When I am working with these equations, finding its domain means that I am going to basically look at my domain rules and apply anything. So it's not a polynomial because you can't have fractional exponents on polynomials. They have to be whole numbers. So not negative infinity to infinity. I can't have 0 in the denominator of a fraction, but that doesn't apply because I don't have any fractions. I do have an even indexed radical. I have a square root. So I know that for my domain restriction, I have to make sure that I don't have a negative under here. So not a negative means it has to be greater than or equal to 0. So what I do, and if you can do this in your head, that's great, but whatever was under the radical, that quantity, in this case x minus 3, has to be greater than or equal to 0. I solve that for x, so x has to be greater than or equal to 3. So that's going to be my domain. I can write it that way. Typically, in upper level math, they may want you to have interval notation. So meaning we start at 3, bracket, because the 3 is included. It's allowed to be 3. And we go to infinity. The book, so you can list it either of these ways unless it specifies. If it says inequality notation, then that's this. If it says interval notation, and this is this. Now, I am not going to require set notation in this course, but I want you to know what it looks like because sometimes the answers will be in set notation. So set notation, you do a little brace, you write the variable, and then you write a line. That line in math means such that. So it's x such that, and then you pretty much use inequality notation. X such that x is greater than or equal to 3. So you do not ever have to use this notation. On a midterm, on a quiz, I won't say write it in set notation. I may say write it in inequality notation, write it in interval notation. But this one, I just want you to recognize it because sometimes the answers in the back are those values. All right, if I look at B, this is now asking me to find f divided by g of x. So that's the same thing as f of x divided by g of x. Order is, of course, important. So f divided by g of x is going to equal f of x, which is this guy, divided by this guy. You do not need to rationalize when there are variables under the radical. If that was, square root of 5, yes, we would rationalize the denominator. But when it's variables, it really doesn't help us a whole lot, so you are allowed to leave them like that. So actually, there's nothing I can do here to simplify because there's nothing that's going to cancel. Even if I went to try to factor the numerator, there's nothing that's going to reduce. So I can just leave it just like that. That's my first part of my answer. For the domain, I have the same thing as I did over here in that I know I can't have a negative under this radical, but because this is in the denominator of a fraction, that means that this also can't be 0. So instead of x minus 3 greater than or equal to 0, there's this tiny variation where it's just strictly greater than. So my domain, I can either, when I add 3 to both sides, say x is greater than 3, or in interval notation, I would use a parenthesis this time, because remember, parenthesis means I don't include the endpoint. Bracket means I do. And so those would be my answers there. All right, last one for example 2. So this is asking me to find g minus f of 4. So notice, this guy is a value, not a variable. So there's more than one way to do this. You can either, this means the same thing as g of 4 minus f of 4. When it asks you to do these given a graph, you will want to do it this way because you look, okay, what's the y value on the graph of g when x is 4? And you just look and find it. And then you do the same thing for f, okay? On the graph, when x is 4, what's the value of my f of x? So if you're using a graph, you'll have to do it this way. If I do it this way algebraically, g of 4 means plug in 4 for x in the function named g. So here's g. G of 4 means plug in 4 there, minus f of 4. Now f of 4 is going to take a little longer because I have to do the opposite of 4 squared plus 2 times 4 minus 1. So everything in here first. The opposite of 4 squared is negative 16 plus, this would be 8. So negative 16 plus 8 is negative 8. Minus 1 is negative 9. So essentially, I've got this. Square root of 1 is 1. So that's 1 plus 9, which of course is 10. The other way that you can do this is to plug 4 into g minus f of x. Now, you wouldn't do this unless you already knew what g minus f of x was. I have g minus f of x over here, so I could just plug 4 into this simplified version. It does not matter. You should get the very same answer regardless of which way you do it. Again, if you're using a graph, you're going to be doing this anyway. But 16 minus 8 is 8, plus 1 is 9, plus 1 is 10. We get the same answer. Obviously here we don't have a domain because it's just an individual value that we're finding. All right, last examples. Let me see if I'm going to zoom in a little bit here and see if that helps make things a little bit bigger, because we're going to have more work on this example 3 than the other ones. So this says find the difference quotient for each function. Be sure to simplify. So difference quotient formula. I think this is the first formula we have that you do not have to memorize. So if you are asked to find a difference quotient, you will be given the formula for this. So this one you do not have to memorize. So it says we are going to take f of x plus h. What does that mean? Well, just like up here where f of 2 means to plug in 2 for the variable, this means I'm going to plug in x plus h for the variable. So when I do a difference quotient, I usually write difference quotient equals over to the side, and then somewhere else I find the pieces. So the first piece is what we just talked about, f of x plus h. So that means that in this f function, I'm going to plug in x plus h in place of the variable there. So negative 2 times x plus h plus 3. And I'm going to simplify it. So distribute negative 2x minus 2h plus 3. None of those are like terms, so there's nothing else I can do with that. So once I have found that, then I'm going to go back over to my difference quotient. This is f of x plus h, so that's what's going to go first, because it's that minus f of x. So f of x plus h is this, then minus f of x. Here I'm going to make a squiggly to separate. So minus f of x itself, so that's just negative 2x plus 3, all divided by h. Now I need to simplify. So obviously I need to distribute my negative over here. So these first ones I'm just going to recopy. Minus a negative becomes a plus. And then this becomes a minus. Carry down the over h. Now I'm going to find like terms. Let me grab some highlighting here, because that might be helpful for this guy. Let's see. So when I look at these, I've got negative 2x and positive 2x. Those are like terms. So in this case, those happen to cancel each other out. I also have like terms with the constants. So plus 3 here and minus 3 here. When I combine those also cancel out. So the only thing in the numerator that doesn't have a like term is this minus 2h. So that's all that's left over h. Then I can simplify again because these h's are going to cancel each other out. So my difference quotient in this case simplifies all the way down to negative 2. All right, I'm going to do this one more time to illustrate a difference quotient. So again, And I'm just going to draw separators here so we don't get confused. The first thing I'm going to do is I'm just going to find f of x plus h before I even start plugging things into the difference quotient. So again, this notation means take the variable, which in this case appears twice, and replace it with exactly what's in the parentheses. So in place of that x, I'm going to put x plus h. It's got the squared on it. Then minus 3 in place of the x, I again put x plus h plus 1. And now I'm going to simplify. Now this time simplifying is more complicated because this is a binomial squared. We've already reviewed how to deal with that. That means x plus h times x plus h. So you have to double distribute or FOIL. If you know the shortcut, which I do, that's what I use. Square the front, multiply the middle together, and then double it. So 2xh, square the back. So this is what I get from squaring x plus h. Then I have to distribute here, so minus 3x minus h, and then don't forget my plus 1 on the end. So now I'm ready to plug into the difference quotient. I better write small because there's a lot of it, right? So f of x plus h, still copying, then minus f of x, so the original function, so x squared minus 3x plus 1, whole thing divided by h. So distribute, so I'm just recopying this first part here. So this becomes a minus x squared. This turns into a plus 3x. This turns into a minus 1 all over h. Now simplify in the numerator. So I've got x squared here and negative x squared there. I have got this with this. So those pair up. Then what else do I have? I have this guy with this guy. Notice how all of these happen to be canceling, right? And what I have left, none of those are like terms. So if I bring down what I've got, 2xh plus h squared minus 3h, all divided by h, all of them have an h, which means technically you can factor the h out, right? That is what allows you to cancel these. And so my final answer is simply 2x plus h minus 3. Now, I always get students that ask, if I can see that all 3 of these have an h, is it okay if I don't write the factoring? Yes, that is okay with me, as long as you know that the reason that works is because of factoring, because remember, we're only allowed to cancel things that are separated by multiplication. So sometimes people ask that, and then they start canceling things that they're not actually allowed to cancel. So as long as you know why that is the way it is, that's totally fine. All right, so we've done a lot of different examples. Every function is going to be different, so we're not going to be able to look at every practice problem and say it looks just like this, but the directions should match up as far as what you are asked to do, finding difference quotients, finding, different function operations, as well as domain, range, and all of that. All right. Have a good one.